you might try. Okay, so we already went through and added the information about the bearings. So that would certainly be the first hurdle, making sure you know how to read those. And then if we're trying to find two things, the distance from A to B, I'm going to call that X. So the distance across this pond or swamp, and then we can go back and give the make our own bearing from A to C. So most of our thought should be trying to figure out this length X. So the first, you're not going to just look at this and know the answer, so you kind of have to work backwards. You have to say, if I want to know a side of a right triangle, I need Pythagorean theorem or SOHCAHTOA equation. Pythagorean theorem, I'd have to know 2 of 3 sides. Looks like finding this side would be kind of hard. SOHCAHTOA, I need a right triangle, which I have, an acute angle, which looks like I might be able to find, and a side length. So that gives you a hint about what you need to be trying to find. So if I can ever figure out this angle at C, I could say, all right, I'm trying to find opposite when I know adjacent. So tangent at C is opposite over adjacent. So really the big hurdle here is to figure out how big that angle C is. If we can figure out how big angle C is, then this SOHCAHTOA equation should solve it for us. Alright, so we've got some angles here. They seem kind of unrelated. But they're really not. They are to help us find that. So we could find out, like, well, we could figure out some of these smaller pieces, and like you could figure out this part of this right angle, this 90 degrees, if 32 of it's here, then 68 of it's there, or 58, because that makes them add up to 90. But the thing that I'm pretty sure that you wouldn't have thought of, because you haven't had to use it yet this year, but we will use this several times now in word questions. When I drew in this bearing, this is a north line, and I drew in this bearing, this is a north line. So if these are both north lines, then you agree that these two lines have to be parallel. Correct? Okay, now I can't turn my paper, but you should probably turn your paper, because students usually see it a little bit better. When you have two parallel lines, and then you have some other line come in here and touch both of those, that's called a transversal. One of the things that you did in geometry is you talked about all these different angle relationships. You learned their names, corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and you should have learned that when these two sides are parallel, same side interior angles are supplementary, corresponding angles, alternate interior angles, alternate exterior angles, all of those are the same size. So when I look at this, again, to me, I'd really like to turn my paper, but this angle that's 58 is an alternate interior angle with this angle down here. Because these lines are parallel, this angle has to be the same, so it's 58. And now if I know this is 68 and this is 58, how does that help me find this angle? Right, because these three make up half a circle, so you could subtract off those two to find this angle, which is angle C. So in math, this is what we like to call a angle chase. You basically just plug in some angles that you can find until you stumble upon the one that you really wanted. So 54. So it looks like that length is whatever 50 times the tangent of 54 is. And now we know the distance across the pond. or swamp. So you need more angle information, and there might be another way. I'm not going to say that there's not, but I've never explored it enough because this is by far going to be the easiest. North lines are parallel. This line's like a transversal. Alternate interior angles have to be the same, and as soon as you figure out this angle is 58 as well, then it's not too hard to find that angle. But if you don't consider the parallel lines and alternate interior angle, you're probably never going to find out enough about the angles. Okay, the other thing that I forgot here, find the bearing from A to C. So if I was standing at A and I wanted to give directions to head to C, we could start at the north line, and I would like to turn right, so that would be towards the east, and the amount I would have to turn would be 58. I needed that for part B. From the north line, turn 58 degrees towards the east line. Okay, any follow-up questions to the steps that went with that? Yeah.
I was gonna can I backtrack? It's like a fast question.
Okay.
How did you get 120 on number 20?